we're going to be covering 7.1. We're starting chapter unit 7. And this is intro to polynomials. A polynomial is an expression consisting of many terms. Examples of that are 5, that's a polynomial. -6, that's a single term, but it's a polynomial. 4x squared minus 1, that's a polynomial, but actually has 2 terms. 9x to the third plus 4x squared minus x minus 2 is a polynomial, and it actually has 4 terms. 1, 2, 3, 4. This is -x, -2. Standard form, this is the way it should be written, okay? Must be written in alphabetical or ABC order, comma, with the highest exponent first. So it has to be in ABC order with the highest exponent first. Okay, so let's work a couple of examples of those. So if I look at this right now, okay, x is the only variable, so that's all I have to worry about. The next thing I look at is the exponent. Remember, when it's just 3x, when it's just an x by itself, it's understood to have an exponent of 1. So I have to rewrite this. This is going to be 2x squared plus 3x. It's plus 3x because that's a positive 3x plus 1. This is standard form for a polynomial. Excuse me. Okay, jumping down, we're going to look at number 5. Remember, it's ABC order, so therefore A obviously comes first. So I have to put the highest A value exponent first, which is A to the third. So I'm going to have A to the third first, and I'm looking for my next highest A exponent, which is this term here. So I have plus 5A squared B squared. So 5A squared, because A squared is next. I'm not looking at the B's at all right now. I'm only looking at A's because that comes before first. Then I'm finding my next A term, which is 2AB. So I have plus 2AB. And now I've taken care of everything else. So now I look at my B's. I'm not worried about, I've done everything else. So the only B I'm looking at is this last term here. And that's a negative, because it says minus 2B, that's negative 2b to the third power. And there is the final standard form. All right, next topic. We're talking about the degree, okay? That's determined, okay? The degree is like for this is the third degree. It's the highest exponent. The highest exponent determines the degree. And it's also what we label it by. So when I'm looking at this, if the degree is 0, that means it is considered a constant. There are no variables. No variables. When it's a constant, it's just the number by itself. Okay. 1, a degree of 1 is considered linear. Means the exponent is a 1. 2, it is considered quadratic. Three is called cubic. 4 is quartic. And that's as high as we're going to go. Everything above that would be like 5th degree or 6th degree. 5, you would say 5th degree. 6, you would say 6th degree. Okay, and for the number of terms, if it's one term, it's classified as a monomial. Okay, if it's 2 terms, then it is called a binomial, just like a bicycle has 2 terms, binomial. A 3 terms, it's just like a tricycle. This is called a trinomial. Anything above 3, 4 plus, you classify as polynomial. Okay, so if we're looking at classifying, so my directions here are to classify by its degree and the number of terms. So if I'm looking at number 1, I'm sorry, not number 1, number 7, that's 6. There's no variable. It's 1 term. There's no variable. This is called a constant monomial. Okay. Number 8, that's 1 term. So it's a monomial. The variable only has a exponent of 1. So therefore, this is a linear monomial. 9, this has 2 terms, exponent of 1, so this is a linear, and yes, you write the full word. Linear, this is 2 terms, because that's 1 term. When it's divided by plus or minus, that separates the terms. And this is a binomial. Jumping down, we'll keep going. This is 2, so that's quadratic. 3 terms, trinomial. Number 11, 3 is the exponent. So I'll come up here and I'll look, 3 is cubic. So this is cubic binomial because it has 2 terms. Number 12, 4 is the highest. So this is quartic. Quartic. 1, 2, 3, 4 terms. So we just say polynomial. Can't see those. Sorry. Cubic binomial because it's 2 terms. 1, 2, 3, 4. Quartic. Quartic is because the exponent is 4, and then polynomial because there's 4 terms. Okay, next page. On the back of this page. This is where we're going to talk about adding or subtracting them. Okay. With these, you're having to combine like terms. The thing to remember is combine like terms and follow integer rules. Follow those integer rules. All right, so if I'm looking at this first one, I'm going to rewrite this without have to, but I'm looking at combining. I'm going to put my like terms together. So I'm going to have negative x squared plus, because I'm adding, plus 2x squared. And I'm going to go ahead and start with the highest exponent first. Kill 2 birds with 1 stone. Why not work it in standard form order? Plus, now I'm looking at my next one, so that's 11x plus negative 5x plus 13 plus negative 23. And now I combine my like terms. So that's a negative 1. So that's going to give me x squared minus 4x, because 11x plus negative 5x is not negative 4. That's going to be 6x. I was seeing that as 1, not 11. So that's going to be plus 6x, and then I have 13 plus negative 10, that's a negative 10, so that's going to be minus 10. So here is my standard form. Now we're going to look at it when it's a negative. This is where the curveball is thrown to us. You have to take this negative and distribute it to everything inside. Okay, so that means this can be rewritten as plus negative 7x plus negative 3x squared plus negative 1. And now if you want to, one way that's shown on the completed notes is you can kind of underline or box your like terms if you want to, instead of having to rewrite it all together. So my highest term is the x squared. So therefore I know I'm going to do the 4x squared plus the negative 3x squared, and that's going to give me x squared. And then I'm going to have 5x plus negative 7x, that's going to give me negative 2x. And then I'm going to have, all I'm left with is the negative 1. So I have minus 1. There's my answer. Moving right along. We're going to jump down to number 15. And again, we're combining our like terms. What we notice here is always look for the highest exponent first. W to the third. There's not anything to combine that with, so I just write that down. W to the third. Now I'm looking at my next exponent, highest exponent. That is, pay attention, we're adding here. So I'm going to have negative 2w to the squared plus 3w to the squared. So that's going to give me, following my integral rules, I actually subtract, so that's plus w squared. And then we have negative 5 plus negative 11, which is negative 16. And it's written in standard form for me already, and I'm good to go. All right, jumping down. Let's look at 26. Okay, the reason I want to look at this is you've got to pay attention to the wording of this. Because it's got wording in here, you may have to rearrange. It says to subtract 2w minus 5w plus 17 from. That means I've got to flip-flop the order. So I've got to rewrite this, and it's going to become w to the third plus 6w squared minus 2, subtract, parentheses, 2w squared minus 5w plus 10. Now I'm going to do my subtraction. Okay, so I'm subtracting. So I'm going to be doing, look at my exponents first, w to the third, there's nothing to subtract there. So I can just rewrite that. Oh, before I go any further, I've got to distribute this. So this is going to be plus negative 2w squared. Then I have plus, that's a negative times a negative. So this is going to become a positive 5w plus negative 10. So now I'm no longer looking at this. I'm now looking at this. So now I've got 6w squared plus negative 2w squared, which is going to be plus 4w squared. And then I have 5w. There's nothing to go with the 5w, so I just write 5w. And then I have negative 2 and negative 10. So that's going to give me a negative 12. So we get a final answer of w to the third plus 4w squared plus 5w minus 12. Yeah. Oh, cut the screen. Excuse me for that. So we have w to the third plus 4w squared plus 5w minus 12. Got any questions? Make sure that you're asking as you go along, or pause it and re-listen. Have a great day.